Our mousetrap uses the law of conservation of energy, which says that energy cannot be created or destroyed. Energy is defined as being able to do work, and work is the displacement of an object. So if the mousetrap goes further, it does more work. Potential energy in this case is when the mousetrap is locked and loaded before the string is being pulled. As the car moves, kinetic energy starts taking the place of potential energy. The same amount of energy stays, it's just a matter of what kind of energy it turns into. After kinetic, the friction slows down the car eventually because of the heat created by the wheels. When the car completely stops, both potential and kinetic energy is completely converted into heat energy.
Newton's first law is the law of inertia. An object at rest will remain at rest unless acted upon by an unbalanced force. When the string is pulled, the car goes because it was acted upon by an unbalanced force. Friction is also acting on the car because it's pulling the car back. It's going against it. Newton's second law says that the greater the mass, the greater the amount of force is needed to make the car accelerate. We are an outside force that acts on the mass by pulling the string to make the car accelerate. Newton's third law is for every action there is an equal and opposite reaction. Friction works against the car because the force is pushing back.
There has to be some friction between the wheels and the ground so an object doesn't slip all over the place. Wheels do reduce friction because they create less resistance on the object, but wheels don't cancel out all friction, they only cancel out some friction. A wheel and axle works by making work easier by changing the amount of force applied to a load. The object being moved is located at the axle, allowing the force to be applied over a bigger distance with little effort. Although using wheels causes the object to have friction between the wheels and the ground, the biggest force of friction is between the wheels and their axles. The axles obtain the most amount of friction because the interior of the wheels rotate on the interior of the axles. The frictional force doesn't depend on the surface area of the object, the friction depends on the object's mass. When friction is reduced, it takes less force to move an object. We are decreasing friction between the object's wheels and the ground and the wheels and axles by constructing the object with the lightest mass possible so it will take less force to make it go a greater distance. Shortening the length of the mousetrap's lever arm would cause the force applied to the object to decrease. Enlarging the length of the lever arm would increase the force on the object because the lever arm controls the amount of force applied to the drive axle that causes the axle to rotate, therefore causing the object to move, so any adjustments to the length of the lever arm will directly affect the outcome of how far the car moves. Adjusting the length of the lever arm will also affect the amount of energy transferred because before the arm snaps, the object's potential energy is high and the kinetic energy is zero. But if the arm is shortened, the amount of kinetic energy transferred will be decreased because it will go a shorter distance, and if the lever arm is enlarged, the amount of kinetic energy will increase because it will go a greater distance. Power is work divided by time, and work is force times distance. So adjusting the lever arm will affect the object's power by if we shorten the arm, then less force will be applied to the car and it will go a smaller distance, therefore doing less work and having less power. But if we lengthen the arm, more force will be applied to the object and it will go a greater distance, and the object's rate at which the energy will be transferred will increase, making it have more power.
Almost everything you do on this earth uses energy. For example, when you rub your hands together, it creates heat. You're starting off with potential energy because your hands aren't moving. As you start to move them, you use more kinetic energy. As you go faster and for a longer amount of time, your hands start to get hot, which creates all of the heat energy in between your hands.